So, was you about to ask a question? Who was that? You, Isaiah? All right. Let's do the last one, and then I think there's that one right there. Yeah, yeah, yeah. All right. Let's do this last one right here. I'm gonna let y'all uh mull it over for a second. And if you wrote on the screen, could you go ahead and erase it so we can have that space? I don't know who drew this second one. Thank you. So is there any difference here? Do you see your 4 pi system?
Yes.
Yes.
Yeah, it's right here, ain't it? That's my diene. And then that makes this by default our diener file.
Dr. Russell, is this in the homework that we have to turn in?
Yes. It's in the assignments folder in Blackboard. And it's labeled Cycloaddition handout 1 and handout 3. It's the only 2 Cycloaddition handouts that you can see, because the other ones I didn't make them available, because we're only going to be able to, with the 2 weeks of spring break and then Easter break coming up, we're only going to be able to hit like the highlights for this. We're not going to be able to go into a lot of detail, but I'll give you what you need. Anybody got the product yet?
Yeah.
Yeah.
Yeah, I do. I just don't know how to write on the screen.
Is it 2 6-member rings fused together?
Yeah.
Okay.
Yes.
All right.
Yes.
All right. All right. I think we're making a move. So this is one of them. Yeah. And then this is your other one with the diene, with the alkene here. Yes or no?
Yep.
If you didn't get that, tell me what the problem is.
Dr. Russell, does it matter which I put a double bond on the second ring. Is that okay?
No, it's
I did
not.
the same thing.
Can you
And
throw it up to your screen again?
Oh, okay, because I had it flip flop.
yeah, but so do you put the double bond here on that side?
No, I put it like right
here?
Mm-hmm.
Yeah, no. We can't, that can't be the product, and I'll show you why. So if we do the mechanism, we'll see why. So this is coming here, right? This pair of electrons coming here, and then this one is moving here, right? So the 6-member ring that was already present didn't change. But now you got a sigma bond between, gotta change colors, between these 2 carbons and these 2 carbons, right?
Right.
And so those sigma bonds are going to be here and here, right? And then
Okay.
you following? And then the pi bond that got shifted is going to get shifted to here.
Okay.
Right. So that's why it's got to be in that specific spot. So it's got to be right here. Right. Are you following that?
Yes.
Okay. All right, cool. All right. Any other questions about this? We're going to hit this one more time. And then we're going to start that other reaction, because I can't give you everything about it because it's just not, we got less time than we need. So I'm just going to give you the highlights. And I think we'll work through some other examples in this handout. Yeah, we'll work through these on Friday when we come back. And then after we work through these, we'll work a couple of other examples. Let me find them. Yeah, we got a bunch of examples in here. We'll work through a couple of these that are highlighted, and then we'll move on to that next topic, because I don't want to run out of time before we get to the reactions. So I'm gonna cut that NMR lecture down quite a bit too, because we've already talked. If you took part 1 lab, you already have some experience with NMR. So we're gonna stop. Anybody have any questions before we cut out?
I got a question.
Yeah, go ahead.
For the 2 pi, for the LUMO of the 2 pi, how is that different from like the LUMO of the 4 pi?
Okay, good. Okay, so the LUMO of the 2 pi, first of all, is different because it only has uh, two p orbitals in it. Are you following?
Yeah.
And then it's lower. It's a little bit lower in energy because it's really only one energy level above the HOMO in the 2 pi, whereas the LUMO of the 4 pi is two energy levels above the lowest energy level. Are you following?
A little bit, yeah.
All right, hold up. I can put it back up. Let me do this right quick. I just need to share this again. Let me go back to that first handout. Oh, that's not it. It's here. Right. So do you see here? Right. This is the 2 pi. This is the HOMO, and then this will be the LUMO.
Oh, so just those two. Okay.
Mm-hmm. Right. It's always so you have to consider how many molecular orbitals you have, and then how many electrons you have, and then you fill each molecular orbital accordingly. Right. So with a 2 pi system, I only got 2 pi electrons. Right. So those are going to go here in this, and so this is going to be the HOMO of a 2 pi system, and then this is the LUMO.
For the 4 pi system, the HOMO was the first one or the second one?
It's the second one.
Okay, got you.
Right, because the HOMO is the H is for highest occupied, or highest, and then the O is for occupied. So both of these are occupied, right? But one of them is higher in energy than the other. So the one that's higher is what we call the HOMO.
Okay, cool.
All right, does that make sense?
Yeah, it does.
All right, bet. All right, any other questions? And we got a good number. We had 49 people. We had 52 people logged in actually. Yeah, but we down to 46. So I don't know, maybe breakfast or whatever. But yeah, I think this was good. I think we'll just keep doing this like we're doing it. And just like in class, if you ever have a question, just ask it. Don't hesitate. And don't think you interrupted me, because you're not. All right. Anyone else have a question?
Yeah. What time is the study sessions tomorrow?
I think I said 6 to 7.
Okay.
Let me pull up that let me pull up the
Thursday.
schedule. Yeah, Thursday. Tomorrow is Thursday. Am I right? Am I
During the
missing
study
something?
session, are you gonna go over just like practice problems and stuff?
Yeah. Or if you have other questions about stuff that you saw in a video or something like that, yeah. We actually we're probably gonna keep working through this handout, because that study session is really gonna, I hate to say it like that, but it really almost be like it's not gonna be another class because it's not a lecture, but it'll be a way for us to keep working through a topic.